Let's have a look at these two Docker files. I need you to pay attention to the entry point. Look at it carefully. You're going to see that one of them has a square bracket, while the other one does not have a square bracket. Essentially, they both have the same command. While both commands are the same, what they tend to do is different. Go with the first one. It is called the shell form. What does the shell form mean? It means that the shell is the main process which has a PID of 1. Now, this is a problem because the shell is the main process running inside a container, and your application is a sub-process running inside the container. If you execute the container, you're going to see that the PID 1 belongs to the shell process, while your main process has a PID other than 1. What is the implication of this? Now, the implication of this is that whenever your application is supposed to, shut down gracefully by caching signals, application is no longer able to cache those signals and to process them safely. In Linux, we have different signals. We have the kill signals, terminate signals, etc. You are running your container in a Kubernetes cluster and you want to terminate your application or your pod. What happens is that your kubelet or your kernel is going to send a signal. It's going to send a signal to the container to terminate. Usually, it is called sync term. What the signal actually means is that it's just like telling the container that, hey, please, you need to wrap up whatever you are doing and exit. In case whereby your application is not the main process, the signal is sent to the PID1, and the PID1 is not your application, and that becomes a problem. If you are running an application that is processing users' data or processing requests, it means that that application or your process is going to be killed abruptly, which is not good. In order for you to work around this, to make your application or your process the main process with PID1, need to use the second form, which is the exec form. So in the exec form, your application becomes the main process, which means that it can intercept those signals and to react appropriately to those signals. So if a signal is sent to your application to tell the application to wrap up whatever they are doing and to shut down any connection, not to accept any more connection, your process handles it perfectly because it is the PID1. Remember, when a signal is being sent to a container to exit or terminate, the PID1 is the main process that caches that signal. Now, any other process that is running as a sub-process has no access to this signal. And that is why